Hello and welcome to Otten Math. We have just one problem. It's a long problem though, but one problem for practice. We talk about regular polygons. So this is going to be, if I'm not mistaken, number 16 from your textbook. So let's talk about the problem. I have given, let's talk about the diagram first. So I've given the measure of angle T is going to be greater than 105 degrees, but less than greater than 105, but less than 145. And we need to find the set of all possible values for the measure of angle V, given that the measure of angle T can be an angle that would be a regular angle, an angle in a regular polygon. All right, so that might be a little confusing. So let me explain that again. Right, so again, we're given that the measure of angle T is between 105 and 145 degrees. We need to find the set of all possible values for the measure of angle V, given that angle T can be an angle that's part of a regular polygon. All right, so let's figure this out. Step by step, we've got a lot of steps to take. All right, the first thing we need to do is figure out given the restrictions on the measure of angle T, how many different polygons we can create given the parameters that T has to be between 105 degrees and 145 degrees. Well, we know that the measure of angle T as an interior angle of a regular polygon needs to be between 105 and 145 degrees. So what polygons have interior angles that are between 105 and 145 degrees? Well, I know that the equation for an interior angle for a polygon is n minus 2 times 180 divided by n. So I create the inequality 105 is less than n minus 2 times 180 divided by n, or the measure of an angle in an interior angle in a regular polygon, which is less than 145 degrees. So now I'm going to express this inequality. I have 105. I'm going to multiply both the left and right hand side of the inequality by n, and also the center. So I have 105n is less than 180n minus 360, or 180 times n minus 2 times 180, which is less than 145n. Now I'm going to separate these into two separate inequalities, and I'm going to subtract 180n from the left-hand side of the inequality and also from the right-hand side of the inequality. So I'm left with two inequalities. One is negative 75n is less than negative 360, or negative 75n is less than, negative 75n is less than negative 360. I divide both sides by negative 75, and I end up with n needs to be greater than, or the number of sides needs to be greater than 4.8. On the second side, or the right-hand side of the inequality, I have negative 360 is less than 35n after I subtract 180n from 145n. I divide both sides by negative 35, and when I do that, remember we have to change the direction of the inequality. So I end up with n is less than 10.3. So if I write the inequality as a combined inequality, I know that n needs to be greater than 4.8, but less than, or n less than 10.3. So the number of sides I have would be, possible sides of a polygon would be 5, 6, 7, 8, 9, or 10. So I have a pentagon and a hexagon, and I have a heptagon, an octagon, a nonagon, and a decagon. All right, so those are the 6 different possibilities. And let's see what happens when I have a pentagon. We need to find out what the measure of angle T is. And then given the measure of angle T, we're going to figure out what the measure of angle V is going to be. Okay, so I have 5 sides, pentagon. I can figure out what the interior angle is given the formula that we've reviewed. And the formula for the measure of one interior angle in a polygon is n minus 2 times 180 over n. So I'm going to do that for all of the different polygons that I have. So 5 sides, I have 5 minus 2 times 180 over 5 gives me 108 degrees. For a 6-sided polygon, hexagon, I have 120 degrees. Heptagon, I have 7 minus 2 times 180 over 7. Octagon, 8 minus 2 times 180 over 8, 135 degrees. Nonagon, 140 degrees, and a decagon is going to be 144 degrees. And those are for the interior angle. So we've all worked that out. I'll leave you a moment to copy this down if you need to, and I'll come back in just a second. Okay, now that we have the measure of the interior angles, or the possible values for t, we're going to move on and figure out what the value of v is going to be. So remember, going back to our original problem, we said we have this restriction on t. We want the measure of angle t to be an angle such that it would or could be part of a regular polygon. We figured out that possible side numbers, the number of sides for each of the sides where t could be an angle given the restrictions. We found that those were 5, 6, 7, 8, 9, and 10. And then we also, as part of the discussion, I think we forgot to talk about this, we figured out that we could say that x plus y plus t was equal to 180 degrees. And we also are going to say 2x plus 2y plus v is going to equal 180 degrees. So we're given a diagram as shown. This ray t, we'll call it A, bisects TAW, and this ray TW bisects VWA. All right, so as part of the problem, we can see that x plus y plus t is equal to 180 degrees, and then 2x plus 2y plus v is equal to 180 degrees. We're going to use this information to solve for v. All right, so let's take the pentagon first. I have 5 sides. I figured out that the interior angle measure is going to be 108 degrees. So I know that x plus y plus 108 is equal to 80 degrees. I can say, therefore, that x plus y is equal to 72 degrees. Now, I then know if x plus y is equal to 72, then 2x plus 2y is equal to 144 degrees. And if 2x plus 2y is equal to 144, and I know degrees, and I know that 2x plus 2y plus v is equal to 180 degrees, I can say that 144 degrees plus v is equal to 180 degrees, or v is equal to 180 minus 34, or 36 degrees. Right, so we have to go through this for each of the individual combinations. So we have 6 of them. So I'm going to go through each of them rather quickly from here on out, because I'm going to assume that you can pause this and rewrite the equations and the solutions as I go through this. So number of sides is 6. We found the measure of angle t is 120 degrees, so we know x plus y plus 120 is equal to 180 degrees. X plus y then is equal to 180 minus 120, or 60 degrees. So 2x plus 2y is equal to 120. 2x plus 2y plus v is equal to 180. So v in this case must be equal to 60 degrees. All right, moving on, and I know this is a lot of information real quick, so please hold on, pay attention. As we go to side number 7, we found out that t is equal to 128 and 4/7. X plus y plus 128 4/7 is equal to 180 degrees. So I know that x plus y is equal to 180 minus 128 4/7, or 51 3/7 degrees. Twice that, 2x plus 2y is equal to 102 6/7. So v is equal to 180 minus 180 degrees minus 2x plus 2y, or 77 1/7 degrees. Side 8, x plus y, we know that t is 135 degrees, so x plus y plus 135 is equal to 180. X plus y is equal to 45 degrees then. 2x plus 2y is equal to twice that. V then is equal to 180 degrees minus that value of 2x plus 2y, so it leaves me with v equal to 90 degrees. Last part of the problem, 9 and 10. Sides, 9 sides in a nonagon. T was equal to 140 degrees in this case, so the interior angle measure of a nonagon is 140 degrees, so x plus y plus 140 is equal to 180. X plus y then is equal to 40 degrees. 2x plus 2y is twice that, or 80 degrees. V is equal to 180 degrees minus 80, or 100 degrees. Then finally, in a decagon, interior angle measure in a regular decagon, 144 degrees. So I know x plus y plus 144 is equal to 180 degrees. X plus y then is 180 minus 144, 36 degrees. Twice that, 2x plus 2y is equal to 72 degrees. V is equal to 180 minus 72 degrees, or 108 degrees. All right, thanks very much for listening so closely. I know this is a tough problem. I'll catch you next time in Chapter 8 in Otten Math. Have a great day.